Typescript is an amazing tool. You can explicitly state that foo is a string or a number or whatever type you like, but a lot of times when you're using Typescript, the type is just inferred, done for you automatically. That is actually particularly true when you are running through a function. The opportunities for inference in a function are very large. However, sometimes we don't get the inference we're expecting. So this is just a very simple example, but imagine we have a object called foobar. Obviously it has properties called foo and bar. And at runtime, we're going to get the number 1 and the string hello world printed out. However, at design time, we're given is that foo is a number and bar is a string, and that's typically what we want. But let's imagine that we've created a function called add_baz, rather, because obviously foo and bar, they hang out with baz a lot. So if we had a function called add_baz, and basically in our little function here, what we're doing is we're adding in the property baz. So we can now change this to be add_baz, and disappointingly, foobar, which had been known to be foo and bar, is now just the property baz. It doesn't know about foo and bar. So that means if I'm down here, I can say, oops, foobar, and I press dot to autocomplete, all I get is baz. That's probably not what you were expecting. It's definitely not what you probably want. So we could do better. So I've created a function called better. And instead of add_baz, we'll use that. Foobar now gives us an intersection. So foobar says, oops, just like before, foo and bar are a number and a string, respectively. And then it says, but we also have baz as well. There's absolutely nothing wrong with this type. This is, will work for us as we would expect it to. And we'll get all 3 of those and the appropriate types for them. It's not quite as graceful, I think, in a way, to have that intersection syntax so that these 2 things are separated. And that can get worse if you do this several times in a row. So what if we could do better? Well, we can do better. So let's go to better still and use that. And now what we see is 2 things have changed. Primarily one thing. The value foo and bar, which used to be number and string, are now literals. So they're the number 1 and the string hello world. This can also be really useful at times. It's often in library code that this literal typing is more important, but it can be useful in a normal application as well. And now, again, we still have the adding of the baz string. But imagine we could go one step farther and use best. Now, all of a sudden, foo, bar, and baz, they're all type literals. And they're all part of one object definition. That intersection type is gone. This, to me, is the nicest looking kind of type outcome you could get. The fact that baz is read-only is you can go one way or the other on that one. Obviously, you are the best, so baz being read-only, fine. Anyways, this video will go into how we can control exactly what this function does and some of the tips that I've found in using inference through a function. So to remind everyone, we've got this foobar variable. Even though we set foo and bar to 1 and hello world, right now its type is just baz. And that's because this add_baz function receives our definition, the foo and the bar, and then kind of immediately forgets about it and just returns back what it knows about, which is baz. So that's where we're at. We can very quickly come up with a a much better solution using generics. Now, I'm not going to go into great detail about generics. Generics are kind of a language feature that you find in most strongly typed languages, and they're available in TypeScript as well. They're, often when you look at code, it's going to look something like that. I have a variable t, which is a generic variable, and it's going to represent some sort of type at runtime. So this gives us an additional amount of inference capability in TypeScript, and allows us to say, basically the problem we're experiencing right now is that even though we know that there's a foo and a bar property, this function is just asking for a generic object that has string properties, and the values can be anything, and it doesn't know anything else. So that's not going to be good enough. What we can do is we can just say this is an object t. And at this point, it actually works. So if we go here, you'll see that foo bar and baz are all represented here. So functionally, I can say foo bar, and I will get the right types for all of these properties. So that's a good step in the right direction, although this is dangerously weak in terms of its definition for an object. So in this case, I could also say const should it not work is equal to addBaz 42. Now, 42 is a number, and so what we get as a result is a weird intersection that we don't really mean, right? 42 and then an object which has this property. That's clearly not what we want. So what we need to do is constrain t, and fortunately TypeScript makes that quite easy. So we can just say extends our old definition. So we can now say that t must be at least this kind of a shape. But, don't forget what t is. So now you can see that our should not work does not work. We get an error. So that's good. It's reinforcing the right behavior, and foobar does still have all three properties. So with generics, and also the ability to say that a generic must at least do this, we are getting some additional inference from our function. Our addBaz function is better than it was, but we're going to make it better still. And we're going to now aim at the kinds of types that we're getting from addBaz. Specifically what I mean is that, while it's okay that foo is a number and bar is a string, we could be more specific. And what I mean is that foo could be the number one, not just any number, but that number. And that's what we call a numeric literal, or in this case, a string literal. So one easy way to do that is we could just change our definition of the parameter we're passing in. We could just say sconst. As soon as we do that, you'll see that foo is the type is the number one, and the type for bar is hello world. So we've made it a literal. But that requires the caller of this function to get involved and to be explicit that, no, I want the literal type. What if you, as the function author, want to make sure you always get the literal type if it's available? Well, that's what we're going to look at, and we're going to take our generics one step further. So I'm going to just change the formatting a little bit because I think it's easier to see this way. Okay, so what we're going to do is we're going to go from one generic to two. So I'm going to create a generic called an. Now, the naming convention for generics is pretty much whatever you want it to be. There are some conventions. If I have just a very few number of generics, I'll almost always start with T. A lot of people will then use U as the second one. I'm just going to use N here because to me it represents a term narrowable. But again, you can give it whatever name you like. I actually, for more complicated scenarios, really like the scenario where you say T always, and then say narrow, and maybe let's just do that. We'll do, say, T object, okay? So we now have two generic variables, and T narrow is going to also have a constraint. We're going to say it can only be a string or a number. And so far we haven't really done anything. We've just added this extra generic. But what we're going to now do is we're going to take our definition of T object, and we're going to use that T narrow to say, rather than it being any type, what we actually meant was we want it to be, this narrow type of either string or number. Okay, now it's giving me a yellow squiggly because T narrow is defined after T object. But in types, I find that actually that error can be large. It's just an ESLint suggestion, really. So I tend to ignore that. All right, so now if we look at what we have, we've got the same foobar variable with the same add_baz function, but you can see the types have changed. So foo is now no longer a number, bar is no longer a string. They're actually the literal definitions. And in general, I would say that as a function author, it's better to try to get those narrow types in most cases. You want to get a narrow definition if it's available. Now, I mean, if this variable 1 was not available as a literal, it's just a number, you can't recreate that. It still will just remain the wider type. But it gives you the opportunity to get that literal type. Last thing in terms of literal types, and as you can see, foo and bar are literals, but baz is not. So let's just make baz a literal too, and the easiest way to do that is just to say this is a constant. All right, now we have literals for all of them. The problem we have now is not about the narrowness of the types, but rather that we have a type intersection. It doesn't really matter in this case. Foo, bar, and baz, I can look at that and see exactly what type this is. But honestly, you find yourself often iterating over an object and adding additional properties. And when you do, this type can very quickly become unintelligible, even though it's functionally correct. What I want instead is to have just an object definition which has all three properties in it. So let's do that. The way we're going to do it is we're going to create something called a type utility. So I'll create a type called pretty, which takes a generic. Okay, so we're going to do something now that we haven't done before, and that is we're going to add a conditional type to our type. So pretty T is going to receive T, which is anything. But we're going to make a conditional statement. We're going to say T extends record string any. And if basically it's a test. It doesn't mean that T does extend record any, string any, but that if it does, then make this a type of, and we'll just say any for now. If it's not, then it's type never. All right, so that's the basic structure of our type utility. If T extends this, then make it any type, otherwise make it never type. Now, we're going to make this into a better definition. So what we really want to do is we want to take the object T that we're given, and we're going to iterate on each property. So we'll say K in key of T, and that's going to be equal to TK. All right, so that's our type utility. Now, before we use it, we actually have to make one small adjustment, and that is our add_baz function has always had an implicit return. It's been working that way. Generally speaking, you do want to make functions explicit in their returns where possible. I'm going to cheat a little bit here just for brevity, but in this case, to use our type utility, what we're going to redefine the return type and say s pretty, and we'll say T object, which is the input object, intersected with the type of baz. Okay, so now we're using this pretty utility, and if we look at foobar, we can see that it is just an object definition. So we have now gone through all three areas that we talked about, those being, again, making sure, one, that we don't lose out on these foo-bar variables by using generics. Number two, looking at using a second generic to ensure that we get narrow types rather than the default wide types. And then three, create a little type utility which iterates over each property in the object and gives us a prettier type definition that people will understand without having to look twice. Okay, hopefully that was helpful. And if you couldn't tell, this was the first video I've created in a very long time, and I have no idea what I'm doing with Final Cut Pro. Years ago, I used Adobe Premiere, but in any case, I plan on making more videos, and if you like this video, it was useful, go ahead and click the like button and subscribe, and hopefully the production quality will improve rapidly over the next couple videos.